Today we are going to start with the new topic, isolation, identification and analysis of phytoconstituents. There are specific phytoconstituents or chemical constituents of different classes of secondary metabolites which are given in your syllabus. Now over here, there are 4 specific categories: terpenoids, glycosides, alkaloids and resins. These are the secondary metabolites. In today's lecture, I'm going to cover the secondary metabolite, that is terpenoids, which are the drugs containing the volatile oil or essential oil, wherein we are going to learn and understand about the isolation, identification, and how to analyze the specific phytoconstituent like menthol, citral, and artemisinin by using modern methods of chromatography and spectroscopy. Now, before we actually start with the specific drug, let us understand some of the very common terms. Before we understand what is isolation, we should know what is extraction. So what is extraction? Extraction, it is nothing but it is a process which is used to obtain compounds. Over here, compounds, I'm referring to different phytoconstituents which are present in the plant material. So any morphological part of the plant material, it is bound to contain specific phytoconstituents. Okay. So the different morphological part, it can be stem or a bark, a leaves or a root or a seed. So that is extraction. So when I carry out the process of extraction, I can use the common methods of extraction, for example, say Soxhlet apparatus, or I can go for another conventional methods of extraction like percolation, digestion, maceration, or I can go for modern methods of extraction, for example, say supercritical fluid extraction, microwave assisted extraction, or ultrasonication. So these are the different methods of extraction wherein I am able to obtain different phytoconstituents from different morphological parts of the plant material. Now, what do you mean by isolation? Isolation is nothing but it is a process of separation of obtaining a pure compound from the plant extract. So possibly from the plant extract, there are a wide array of phytoconstituents or chemical constituent, and my objective is to separate the purified phytoconstituent or a pure compound present in the plant extract. So that is called as isolation. Usually, isolation is carried out in the laboratory by the technique or the method which is called as column chromatography. Now, we go to the first category or first class of the compound, that is isolation and phytochemical analysis of terpenoids. Now, what are terpenoids? Terpenoids are nothing but these are hydrocarbons of plant origin, and they have the general formula of C5H8N. So this is the one isoprene unit or N number of isoprene units which are designated as terpenoids. They contain both hydrogen and carbon. That is the reason they are called as hydrocarbon. These terpenoids are either oxygenated, hydrogenated, and dehydrogenated derivatives. Basically, terpenoids are volatile substances which give fragrance or aroma to the plants. They have got very good aroma or fragrance, and usually it is used in the perfumery industry. Terpenoids, they are also called as essential oil. Why? Because they represent essence. Mostly, the drugs containing terpenoids, they are also called as aromatic oils. The drugs like dill, caraway, coriander, these are usually used as anti-flatulents for relieving flatulence, and they are mainly used for preparations containing aromatic waters. For example, say marketed products like gripe water, or what you can call it as aromatic waters. Now, these terpenoids, they are mainly found in leaves and fruits and in plants like either conifers, citrus and eucalyptus. The word or the term terpene, it is assigned to the compounds after isolating the volatile liquid, that is turpentine, from the pine tree. So we are getting turpentine oil from the pine tree, that is Pinus palustris miler, belonging to family Pinaceae. So from there, the word terpene came into the picture. These terpenoids, mostly they are colorless, fragrant liquids, usually lighter than water and volatile in nature. So most of the drugs containing volatile oil, they are lighter in water, but there are certain exceptions wherein the volatile oil is also, it can be heavier than water. Now, in general, depending upon the number of carbon atom, these terpenoids are classified as monoterpenoids and sesquiterpenoids. And also, there are certain phenolic compounds which come under consideration of essential oil components. They are volatile in steam and therefore they can be isolated by using appropriate apparatus. So, terpenoids, as I discussed earlier, they can be classified depending upon the number of N units, that is number of carbon atoms or number of isoprene units. C5H8, it represents 1 isoprene units. So the classification is mainly done on the basis of the value of N, that is total number of isoprene units or the number of carbon atoms present in the structure. So if there are 2 isoprene units, that is C5H8 multiplied by 2, so it becomes C10H16, then it is monoterpenoids. If there are 3 isoprene units, that is C15 carbon atom, then they are called as sesquiterpenoids, that is C15H24. If there are 4 isoprene units, then it is C20H32 diterpenoids. If there are 6 N value, then it is triterpenoid, C30H48. Similarly, if there are 8 isoprene units, C5H8 multiplied by 8, then they are called as tetraterpenoids. Tetraterpenoids, they are also called as carotenoids. If there are 10 isoprene units, okay, then they are called as pentaterpenes, C50H80. And if there are n number of units, then they are called as polyterpenoids. So, depending upon the type and the number of rings which are present in the terpenoids, if it is a straight chain compound, then they are named as acyclic terpenoids. If the terpenoids are containing 1 ring structure, then it is called as monocyclic terpenoids. Example is menthol. If there are 2 ring structures, then they are called as bicyclic terpenoids. If there are 3 ring structure, then they are called as tricyclic terpenoids. There are some terpenoids which may contain open chain structure, or it can be a closed chain structure as well. Now, if I want to isolate the specific volatile oil or the specific constituent which is present in the volatile oil or essential oil, usually Clevenger's apparatus is used. Clevenger's apparatus, it is also called as the Karlsruhe apparatus. It has proved the best for quantitatively isolating small amounts of volatile oil present in these kinds of plant material. However, at an industrial scale or large scale industrial isolation, the above Clevenger's apparatus is suitably modified to serve the purpose. Further, isolation and purification of the specific components of the essential oil depends upon the amount of oil available and types of components present in it. So, depending upon which plant material we are selecting, we are going to select which particular plant material and what is the percentage of the specific volatile constituent or phytoconstituent. Depending upon it, the method of isolation and purification can be selected for specific components. Now, how does Clevenger's apparatus look like, or what is the construction working of Clevenger's apparatus? Clevenger's apparatus, it is most commonly used for extraction and isolation of the specific phytoconstituents present in the volatile oil. So, volatile oil, usually they are of 2 types: volatile oil with low density and volatile oil with high density. There are 2 designs of Clevenger's apparatus which are available. N-shaped type of volatile oil, wherein the volatile oil which is having low density. Okay. And there is one more design of apparatus, that is the volatile oil with higher density. So it is called as the H-shaped apparatus.